So next, we have a talk focusing on API secrets, tokens exposed, insights from analysing 1 million domains reveals critical risks of the modern web. So please would you put your hands together for Antoine and Carossio. Thank you.
Hello everyone, thank you for attending this talk today. So this talk is more about pen testing at scale. What's on the agenda today? So the first thing I would like to focus on is to explain why looking for API secret tokens in front ends matters today. Then I will explain why it's hard, so this part will be more technical and you will see how we managed to do that at scale. The third part will be more about the findings. I think this is a part you've been waiting for, especially some of the results are really fascinating. And then we will go through very simple recommendations so that developers and DevSecOps teams in companies avoid this kind of secret leaks into front ends. All right. So who am I? I'm Antoine Carossio. I'm the co-founder and CTO of Escape. I graduated in France from École Polytechnique in cybersecurity and UC Berkeley in California. I'm passionate about pen testing. I worked as a pen tester before for the French army, but I cannot write it down. I'm passionate about open source. I'm the co-founder of GraphQL Armor, which is a security solution for GraphQL API. And contrary to most security people, I'm a huge fan of Apple, and I've been working for Apple too before. All right. A few words about Escape. So Escape is a security solution that aims to discover and secure all APIs at scale with a very low time to value that requires no traffic monitoring. So this is a very convenient solution, especially for DevSecOps teams. And it happened that at Escape, we regularly publish, so usually twice a year, white papers and reports, cyber reports, about security. In 2023, we have the state of GraphQL security and then the state of public APIs. So you can still see those reports on our blog. And the talk I'm giving today, actually, is an extract of the state of API security 2024, which is the API Secrets Pro. You can access it directly from the QR code. It gives a lot more technical details, figures, and conclusions about what I'm going to present you in 25 minutes today. All right. So the first question I would like to ask is how can API secret leaks still be a problem today with all the solutions that currently exist to avoid those leaks? It happens that tech is still booming. We've seen Web3 a few years ago. Now it's more about AI, and companies tend to deploy more and more resources on the web. They interconnect those resources through APIs, all right? And it happens that DevOps team, they really try to catch up with that, but they struggle deploying secure assets effectively and securely on the internet. This is assessed by very recent attacks that occurred on some famous companies. So this happens at the beginning of 2024 or end 2023. And the common attack vector here in all of those attacks was that they came from exposed API secrets on the internet. So these API secrets exposed on the internet is still a real problem, and especially in front-end applications. So why does this still happen? Actually, today, the DevSecOps process, so those are the 6 phases of the software development lifecycle. And it happens that security solution has evolved, they have evolved to this new lifecycle, to agile environment development, with threat modeling, static analysis, dynamic analysis, runtime protection, and so on. But what about secrets today? What do we have for secrets? If you want to secure and detect secrets in repositories for developers, you have really cool solutions such as Git Guardian or SemGrep that allow the developers to identify the secrets leaking in their repositories when they are committed and so on. If we consider the pure API part, you can avoid API secret leaks using gateway rules or WAF rules, or using detection solution such as Escape, for example, which is trying to find secrets inside APIs. But what about front ends? It happened that front-end security is a blind spot today, and there is nothing actually to detect secrets in front ends that can leak in production. So why is there nothing today? This is actually the main problem that I'm going to try to explain you in this second part, which is more technical. It explains why it's hard to detect hard-coded tokens, not only during the development process, but also as a pen tester when you're trying to attack the company websites, and especially the front ends. All right. So who in the audience is familiar with front-end developments? Okay. So I would say about 10% of the audience. Okay, so what is really important to understand here is that all front ends, all web applications on the internet, they are actually built with three kinds of files: HTML, CSS, and JavaScript. HTML and CSS are more for the layout of the page, while JavaScript encapsulates the logic of the page. All right. The problem is that developers today, they don't code directly in HTML, CSS, and JavaScript because this will be super inefficient to do that. And that's why they more used frameworks that I'm sure you're aware of. So here you have React, Vue.js, and Angular, which are the most famous today. And those frameworks, those front-end development frameworks, they allow to create very complex front-end applications that are also compatible with mobile most of the time, that consists in sub-modules that are interdependent to each other and that are really specific to the framework. The problem here is that your web browser cannot read these files, those files directly. Those files are really specific to the framework, where the browser can only deal with the static files, HTML, CSS, and JavaScript. This is why it has been something has been created for that, which is called Module Bundler. The most famous one is Webpack, okay? And a Module Bundler typically transforms the complex module with dependencies into static files that are readable by your browsers. This is really convenient, as you can create complex application as a developer, and you don't have to bother about the results that will be read by the browsers. Okay. Here, I'm doing a zoom on JavaScript assets that are bundled by Webpacks. And as you can see, this is pretty indigest, and this is very convenient for two reasons. The first one is that those files are pretty small, so they are downloaded really fast by your browser, which makes the navigation on the web, browsing on the web is really fast thanks to those small files. And also for security reasons, that's pretty good because it's really hard to reverse engineer and to understand the logic of the application, so it kind of protects your applications by obfuscation. The thing is that finding tokens into that soup of code is actually extremely hard, especially if there are tokens that are leaking. It's really hard to identify a token into that soup. Here, I'm going to differentiate two kinds of tokens. The first one are documented tokens, or secrets. For those secrets, actually, it's pretty straightforward to still find them in front ends, by simply using regex. You use pattern matching and you find them in front ends. So normally, the current solutions that are static analysis of the code, they're supposed to find properly those kind of documented tokens. Just very briefly, a parenthesis for this study, I wanted to say that some of those documented secrets are by design not critical if they leak, because they are either scoped tokens, such as for Amazon S3 public links, or Google Maps keys. Those tokens, they are not part of the study. We managed to exclude them from the study because with pattern matching, we just identify them and they are not part of the study. I think it was important to say we only consider in the rest of the study the tokens that are really critical for the business and not public keys or scoped tokens. Okay. The second part, the second kind of tokens that is really interesting, and those are the most interesting actually, are the proprietary and undocumented secrets. Those are the secrets that are really built by the developers of the company for their own usage. They represent, we'll see some figure after, but they represent the maximum criticality in a company because they are really built to access the business logic of the application and so on. And those tokens, they are really hard to find in front ends. Indeed, usually to find tokens and secrets in code, the static analyzers, what they do, they read the code, which is properly structured, especially back-end codes, for example, or pre-compiled front-end codes. And simply by using entropy, so you look for long strings with a lot of randomness, you can identify those proprietary and undocumented tokens in your code. So normally, when the code is structured, this is not a problem. But as we saw just earlier, the JavaScript that is bundled with the Webpack is entropic by itself. So using this technique cannot work alone to detect secrets at scale on the internet, because every string here has a lot of entropy. Okay. On the other hand, one technique could have been to just try to identify all the potential secrets that are leaking in the front ends and to test them. However, this will be super computationally intensive, plus it's completely illegal to try and test the tokens. It would have required a lot of resources, a lot of code to test all the potential tokens. So in spite of that, we decided to really have a novel approach to do that at scale, which is leveraging abstract syntax tree in front ends, and this gives a high confidence signal. All right, so what about abstract syntax tree? I won't enter into the details here because it's quite complex for a conference, but I really invite you to go and download the report again where everything is explained into detail. But basically, the goal here is to restructure the code, okay, to understand the context where the variables we identified, where they are declared and used. And this is particularly relevant because if we find a variable with high entropy in a context where there is an API call that is being made, it is very likely to be actually an API secret tokens leaking in the front end. And this technique actually gave us excellent results, and this is the technique we used. This is actually pretty fun because this technique is also, from a computational point of view, it is really cheap actually. It requires very low computational resources. So I won't enter into the details of the architecture we used, but what matters here is that we managed to scan the top 1 million domains on the internet. We just filtered out some of them because we didn't really want to have problems with the governments, MI6 and so on. So this is why there is a bit less than 1 million. We managed to scan 4 domains per second in parallel for a total of a bit less than 3 days of total scanning. And we scanned a total of almost 200 million web pages. So we made 200 million requests, and we scanned 200 million front-end web pages for a total cost of only $100, which is super cheap. So actually, I will show you right after that this might be the most profitable $100 we invested in the company. All right. So now let's deep dive a little bit more into the results, into what we found during the study. And we'll show you how we traded those $100 against 20 million. Okay, let's take a step back here and take a look at the secrets. Here on this graph, what we see is that more than half of the secrets we found are actually GitHub or GitHub tokens that allow to publish the front ends on the internet directly from CI/CD. I will come back to that after. That's really interesting. We had a lot of private API keys too that are leaking. So those are the undocumented secrets I was talking about earlier. And there is a fun trend here too. Actually, there are a few OpenAI keys that are leaking, which means, this shows a trend of implementing AI everywhere. There was a talk about LLMs just before in another context, but we can see that LLMs are started to be implemented everywhere, and we found a few OpenAI keys leaking, which is pretty fun. I'll come back to that later too. Okay, if we take a global look of what we found, we can see that Brazil here did really bad with almost 7% of the tokens we found leaked by Brazil. And Netherlands in Europe also is the bad student, I would say, of the study. In terms of market sectors, activity sectors, we can see that a lot of those tokens are leaking in the media, gaming, and tech industry, which are representing, in fact, more than 60% of the total leaks. But what is even more interesting here is that when it rains, it pours. Indeed, what we see here is that among the websites where we found at least one token leaking, we, in fact, on average, found at most 2 leaking. On the website, we even found 28, on the domain name, we even found 28 tokens leaking on a single domain. And so this shows that when there is a bad practice implemented, inside a company, it is very likely to be implemented in all the business units of the company. And that's a trend that we managed to confirm by analyzing more the details, more the results more into details, and even by discussing with the application security team that are responsible for deploying those applications. All right. So here, this is a snippet of code that we could find on the internet. This is very dumb code where just a front-end developer decided to hard-code the OpenAI keys directly inside the front-end without talking to the back-end developers or to any architects. So this still exists, actually, which is quite surprising. But more interestingly, I would like to come back on the 55% of Git deployment tokens we found on the internet. Why did this happen? Actually, if we remember the part about Webpack and the JavaScript files that were compiled together, what happens here is that module bundlers, such as Webpack, actually, they tend to take all the files that are within the code repository of the developers, including the environment files, and it tends to pack everything inside the static files and deploy them directly on the internet. So this is why, even though some tokens are still hard-coded by developers, a lot are actually hard-coded not by developers directly, but by Webpack, because the default behavior of Webpack is to take everything and to deploy on the internet. This might be a real problem because in some cases, those tokens, they have high permissions and they just allow to see and to access the whole repositories of an entire organization. So indeed, this is a very bad practice here that we should care about, and this is something new that we discovered during the study that was not really reported before. Okay, some of the critical findings we found. It happens that a third of the secrets we found were actually could lead to an entire business shutdown. So at some point, it happened that we found, don't ask me how, I really never figured out why, but we found some private RSA key inside the front ends directly, inside the JavaScript files, so either as a comment or directly hard-coded as a variable. But more interestingly, we find quite a lot Stripe tokens, all right, which were in most cases read and write tokens, allowing to make bank wires to anyone you want. We found a total of 20 millions in Stripe tokens, including 70 millions on a single token. So I can confirm that this token was fully admin. It was a token of a big US organization, and it could lead to bank wires and so on. It allowed that. And what is really fun is that it was really found in the front end in the web page. It was not that hidden. And just by browsing their websites, all of you could download a file that contains this Stripe token with a lot of money. Okay. So this is the most critical token we found, actually. And this shows that this is still a big issue. All right, so very briefly, how to secure API secrets from being exposed on the internet, especially this is really useful when you're pen testing a website and you want to give recommendations to the development teams in the company. The first thing, of course, so this is super basic, but it's still done, and we saw it with the OpenAI key, is to only make authentified call to external APIs with the backend. Because even if you hard-code the OpenAI key inside the backend, which is still a bad practice, at least it is not downloaded by your browser, and so it is not exposed on the internet, only on your servers, which is already better than directly in the front end. But it happens that the front-end developers tend to be lazy and want to implement things fast without talking to back-end engineers. And this happens to really bad behaviors. All right. The second thing, so this is really interesting because I told you earlier that it was really easy to find tokens while you're coding as long as they are documented properly. So just a simple behavior as a developer is to document your tokens. And one technique for that is to leverage type prefixes. This is pretty straightforward. You have open source implementations, open source libraries to do that at scale in your company. So here, type IDs for Golang, but you have implementations for all the languages. And here, the very good example, the perfect example is Stripe, that actually not only prefixes all of these public APIs token, but also internally they have a strong politics at Stripe, normally to identify, to type all the tokens they use, even the tokens that are just built to be used internally. Of course, store the secrets in vaults, not in .on files, as much as you can as a developer. You have various implementations for that, such as Archicop, AWS Secrets Manager, and other open source solutions. And last but not least, try to use scoped token with expiration dates, because in the case they still leak in spite of all of this, you will be able to limit the damages of a potential leak of those tokens. So those are very basic recommendations, but they are still not implemented in most companies, as it is seen by the studies. All right, so thank you very much. I'm really interested in, I know I usually have a lot of questions after the conference and some technical details, so feel free to contact me directly on LinkedIn. I will be happy to answer you. Or you can also re-download the report directly from our webpage and have more results. If you want the slides too, don't hesitate to contact me. Thank you.